Hi everyone, we're at the Moreland Dixon Road outcrop on the east end of the outcrop on the north side of the road. And here is a very cool example of mullions. And you'll remember mullions are linear features that develop during metamorphism in folded rocks. So I'll point out the mullion lineation in this outcrop. It's these long ridges, this time on the underside of the outcrop, they're visible. And you can see that as we go across the outcrop to these features, we can even see a nice one over here, they're all parallel. And the trend and plunge of this lineation, which is the mullion on the foliation surface, is going to be parallel to the fold axis of the fold. So the measuring trend and plunge here of the orientation of my pencil on this mullion will give you the trend and plunge of the fold axis of these rocks. Hi, so we're still on the outcrop at Moreland Dixon Road on the north side of the road, and here is a great example of a foliation in paragneiss. When we're measuring foliation, remember it's a planar feature, so you use strike and dip to measure it. Of course, you want to find a plane or surface to measure, which an example right here is a perfect one. So if you were to see this, plane, you could put your compass on there directly and measure strike and dip from there. But if you're not so lucky and you have this part of the outcrop here, you can see the line of the foliation on the top face, and then you can see the line of the foliation continue around the corner. So this is a better example of a foliation layer. You can trace with your finger around the front side of the outcrop and around to the top face. And remember, if we define two lines within the same plane, we can define the orientation of the whole plane. So here, to measure the strike and dip, you would take your notebook and hold it along the line on the top face, and with your eyes, make sure the tilt of the book matches with the progression of the foliation around that corner. And so from here, you can measure strike and dip, which will give you about the same answer as strike and dip of that plane up there. So another very interesting thing about this outcrop, from more of an engineering geology perspective, if we come down here, we can still see the foliation plane exposed at the top on that overhang. And we can see this plane here, which is a joint, and this other back face of the joint down here. When the foliation forms and cools during uplift, you can get that tensile fracturing. So from an engineering geology perspective, is a plane of weakness. And in this example, there used to be rock in this gap or this void that actually released and slid down along this joint surface only about 5 years ago.